Thank you for checking out Mr. Ware's videos, and today we're looking at how to solve a system of equations using an augmented matrix. Augmented matrix. So that's what we're taking a look at today. All right, so there are these different operations that you could do to a matrix in order to solve for it, okay? And I talked about this in a previous video, but I'm gonna go over it again, okay? All right, so they call these elementary row operations. You could swap the rows, you could have scalar multiplication, or you could do row addition. And I'm gonna go over them with you right quick. So, so you're gonna use this to process and perform elementary row operations on an augmented matrix to solve the system. So these are the things you're gonna do to solve it. Okay, so let me explain row swapping. It's pretty simple. You just swap the rows. All right, see how this one's down here and now this one's up here. All right, scalar multiplication. Basically, it's like a regular matrix that you're going to scale up. Okay, now it's going to be notated like 2 times R1. That R1 means row 1. Okay, so I'm going to take the first row and multiply it by 2. All right, so I multiply this whole top row by 2, and I got 6, 10, 24. And I left the second row wrong. Scalar multiplication. Row addition. All right. Here, I changed this matrix to this matrix. And what I did is I added the rows. So I did 6 plus -6 to get 0, 3 plus 1 to get 4, and 5 plus 2 to get 7. And they said row 1 plus row 2 placed in row 2. So once I added this, the new row goes here. Can I put it in the top row? I could, but I just happened to put it here. So it's important to read these instructions here. Row 1 plus row 2 placed in row 2. All right. Let me see if this fits. Just one. All right. Now I'm doing scalar multiplication and row addition. So first I scaled it up by multiplying the top row by -3. And so I got -3, -15, and -6. And then the bottom row I just left alone and wrote it again. And now I add it. -3 plus 3 is 0. -15 plus 2 is -13. And -6 plus 1 is -5. All right, now see how I rewrote this in the bottom row here and left the top row alone. Now, the reason I did all that and the reason I have it be that way is to get a particular way of finding the solution. So let me show you. Okay, so this is an identity matrix, a matrix of the form 1, 0, and 0, 1. Okay, this is where we talk about ones and zeros. All right, so here, when you have this, the numbers on the outside is your actual answers. So you could do different things, but as long as you get 1 and 0 and 0 and 1, those numbers on the end are X and Y. That's your input, output. So what does this really mean in terms of a regular equation? Well, it means 1x plus 0y equals -9, and 0x plus 1y equals -13. And once you have that, you know that x is not -9 and y is -13 because 0 times anything is 0. So that's how I know x is equal to -9 and y is equal to -13. So that's the whole goal of doing these different operations to the matrices. All right, so first we're going to start off by using row operations to solve the system of equations. Okay, first I'm going to rewrite the system into an augmented matrix, like so. -5, 3, 6, 1, -1, and 4. All right, Now it says, notice how the first element in row 2 is 1. Let's interchange it with row 1 and row 2. So you want to get 1, 0, 0, 1. So I'm just going to move this top row to the bottom row to the top. So I took this row 1, -1, 4, and just moved it up and just swapped it. Simple swap. All right, to make the first element in row 2 a 0, you want to multiply R1 by 5 and add the results to R2. So see how I got -5? In order to make this 0, I have to add it with a +5. How do I get a +5 here? Well, I'm just going to multiply it by 5. And notice the operation is 5 times row 1 and then add it with row 2. Once you add it with row 2, we're going to place it in the bottom, like so. So then I need 5 times 1 to get 5, 5 times -1 to get -5, and 5 times 4 to get 20. Okay. All right. Then the next step is to add -5, 3, and 6. I added with that bottom row, and the results is 0, -2, and 26. So now I've got the 0, which was the whole goal, right here in this first spot, and I'm going to place it here. So I place this whole thing here, and now I've got this one. Now step forward, let's make the second element, R2, a 1. All right, so we want to make this 1, the second element in row 2. All right, so it's -2. In order to get it to be 1, we have to take half of it. What's half of -2? So we're just going to multiply the whole thing by -2, or just divide it by 2. All right, so I take this whole thing and divide it by -2. I get 0, 1, and -13. So I put -13 over here, and 0 and 1. Almost there. All we need now is to make this right here is -1, 0. So it says to make a second element in row 1 a 0, add the rows together and place the results in row 1. So we're going to add these two together here. All right, so I'm adding 1 and 0. Okay. And we got 1 here, and then -1 and 1, that adds up to get you 0. So now we got that 0 in that second spot like we want. And we're going to do the 4 and the -13, add these constants as well. We got -9, and we got 1, 0, -9. So that's how we get 1, 0, 0, 1, and then -9 and -13. So you write the final answer is -9, comma, -13. All right, let's see what else we got here. All right, so remember, you got to have a 1 and a 0, and a 0 and a 1, and then whatever number here is your answer. All right, so here's another example here. We've got, first thing we're going to do is going to write it as an augmented matrix. It's going to look like this. 1, -3, -2, 4, 1, and 31. Okay? And look, we already got the 1 here and a 1 here. We're getting close already. Let's see what we could do to make sure we get 0 here and 0 here. Okay, so think, what can we multiply, or what can we do to here to make this turn into 0? All right, we're going to multiply the first row times -1, sorry, -4, and then add it with row 2. So down here, when I got the scratch paper, this is what I'm doing. So I'm doing -4. Well, I'm multiplying -4 times row 1. I get -4, +12, +8. And then I'm going to add it with row 2. So that's 4, 1, and 31. And I get 0, 13, 39. And then I plug that in for row 2. Now I got a 0 here. So I lost this 1, but that's okay. I've got a 0 here. All right, let's see what we could do next. All right, what can we do to make this 13 be 1? All right, what we could do there is divide it by 13. So I'm divided all the way across by 13. And you start thinking about division once you get a zero, because you know when you divide that zero, it's going to stay zero. So I guess you can also multiply and get zero as well. But divide by 13. So I am going to divide this whole row by 13. And I get 0, 1, and 3. And I'm going to place that in row 2. So now I got 1, -3, and -2, the same thing I had here. And I got 0, 1, and 3. Okay, so that 39 divided by 13 is 3. All right. Now, last thing I need to do is get this -3 and make it a 0. So what can I do to make this -3 a 0? Okay, I can do 3 times R2, row 2, 3 times row 2, this one. So I can get a positive 3 to add with that and add it with row 1 and place it in row 1. So that's what I'm going to do. Okay, so I got 3 times row 2. So 3 times 0 is 0. 3 times 1 is 3. And 3 times 3 is 9. Now I'm going to add it with row 2. I'm sorry, row 1. So I have 0, 3, and 9. Added with row 1. 1, -3, and -2. This will cancel out. That's what give me 0. And then 9 plus -2 is 7. All right, so I write that in row 1. And look, I got 1 and 0, and 0 and 1. So I know my x is 7 and my y is 3. Okay, so that's a quick little intro to solving systems with matrix. So what I'm gonna do is I'm gonna do a part 2 to this video, but this is part 1. So look out for part 2. But for now, thank you for checking out Mr. Ware's videos. Have a nice day.